Okay, welcome to the deep dive. Today, we're tearing into something really interesting. Seedance 1.0.
Yeah, that new video generation model from ByteDance Seed.
Yeah.
Lots of buzz around this one.
Absolutely. And if you're tracking the latest in AI, especially generative stuff, this is definitely a one you need to know about.
So our mission today, basically, is to unpack the research report.
Yeah.
We want to figure out, what is Seedance 1.0? How does it actually work?
And what makes it stand out? Right. We're aiming this at you technical folks who want the real story behind the headline.
Exactly. We'll try to give you the core insights without getting totally lost in every single detail.
Okay, so for the quick version, the elevator pitch, Seedance 1.0 is basically a high-performance video model.
And it's trying to solve that really tricky problem in video gen, balancing everything.
Right. Getting, great visuals, believable motion, and actually following the prompt precisely, all at the same time.
Which is tough. But the results, look at the leaderboards. As of, Juneteenth?
Yeah, June 10th, 2025. It's sitting top of the artificial analysis rankings for both text to video and image to video.
Topping both is, it's pretty rare. Usually models lean one way or the other.
And the speed, that's another big thing. Generating a 5-second 1080p video.
In just over 40 seconds, right? 41.4 seconds on an L20 GPU. That's fast.
They're claiming a 10x speed up in inference because of their optimization work, which is kind of nuts.
Yeah, and beyond just speed and scores, the paper really emphasizes its ability to follow instructions really closely.
Precise control and getting that smooth, stable motion. Plus native support for multi-shot stuff.
Exactly. Creating narratives, keeping subjects consistent across different shots, all from one prompt. That's a big step.
So how'd they pull it off? The paper points to a few key things.
Right. It seems to come down to, first, really curated data with super detailed captions.
Okay.
Then an efficient architecture, separating spatial and temporal processing cleverly. Then advanced post-training, like SFT and a video-specific kind of RLHF.
And those inference speedups we mentioned, they really pushed on acceleration.
Okay, so let's dive deeper then. Let's really unpack this paper, the problem, the build, the data, training, speed, and how it stacks up.
Sounds good. So that core challenge Seedance 1.0 is tackling. Anyone who's played with these models knows it.
Oh yeah. You get great visuals, but the motion's weird. Or the motion's okay, but it didn't really follow your prompt.
Exactly. That trifecta looks good, moves right, does what you ask. It's hard to nail consistently. You usually compromise somewhere.
So Seedance aimed to avoid those compromises.
Yeah.
Build a model that could handle all those dimensions.
And versatile too, right? Text to video, image to video.
And bilingual English and Chinese prompts from the get-go.
Okay, let's get into the how. You mentioned data first. They seem to put a massive emphasis there. What was the approach?
Data is everything, right?
Yeah.
Especially for these huge models, they sourced widely, aiming for maximum diversity, different lengths, resolutions, subjects, actions, styles.
The whole 9 yards?
Pretty much.
Yeah.
But raw data is messy. So they built this pretty complex multi-stage pipeline to clean and curate it.
Like a super filter.
Kind of, yeah. Several stages. First, they break down long videos into shorter clips, like max 12 seconds, trying to keep the local narrative intact.
Okay.
Then systems to spot and remove things like logos, watermarks, burned-in subtitles.
Got it. Cleaning the visuals.
Then heavy filtering, getting rid of blurry stuff, jittery video, low aesthetic quality, static images, and crucially, safety filters.
Yeah.
Classifiers to weed out harmful content.
Right. Quality and safety built in.
Definitely. They also deduplicate, finding near identical clips and keeping only the best one helps maintain diversity.
Smart.
And they actively manage the distribution. Like if they have too many cat videos, they might downsample those. If they need more, say, specific sci-fi styles, they target acquiring that.
Wow, that's a really active curation process, not just vacuuming data up. And the captions, you said comprehensive.
Yeah, the captions are vital for that precise control. They use what they call a dense caption style.
Dense.
Meaning it captures way more than just a cat sitting on a mat. It describes the dynamic stuff, actions, camera moves, and the static things, characters, setting, overall aesthetic style. Really detailed.
Okay. And they trained a model just to generate these captions.
Yep. Trained on hand-annotated data, works bilingually. And then there's another piece.
The prompt engineering model.
Exactly. So when you, the user, type in a simple prompt like dog running in a field, cinematic style.
Yeah.
This PE model, based on an LLM, takes that and translates it into their detailed, dense caption format for the video model to understand better.
Ah, okay. So it bridges the gap between human language and what the model needs.
Right. And they train that PE model carefully, using SFT and even RL techniques to make sure it rephrases accurately and doesn't, hallucinate details that weren't in the original prompt.
Right. Data sounds like a massive undertaking. Let's shift to the model architecture itself. Efficiency, decoupled layers. What's the core structure?
Well, at the base, like a lot of generative models now, there's a variational autoencoder, a VAE.
Right, for compression.
Exactly. It takes the raw video pixels and compresses them into a smaller latent space. Their VAE is designed specifically to handle video efficiently, compressing both spatial and temporal information together.
So squish the video down first, then the main event.
Then the Diffusion Transformer, or DIT, that's the engine doing the actual generation. It takes that compressed video representation from the VAE, adds the detailed text conditioning from the PE model.
And uses transformer blocks to generate the output.
Pretty much. But here's where the decoupled spatial temporal thing comes in.
Okay.
Instead of having every transformer block trying to understand both how things look within a frame and how things change across frames simultaneously,
They split the job.
exactly. Some layers focus solely on spatial attention, understanding the relationships within a single frame. Others focus just on temporal attention, understanding motion and change across time.
And that helps.
They found it improves efficiency and, importantly, helps the model get both structure and motion right more effectively. Temporal layers use window attention to see across frames efficiently.
Makes sense. And they mentioned handling multiple types of input, like text and image data together.
Yeah, they build on the MMDIT architecture ideas. That lets the spatial layers handle both visual tokens and text tokens effectively, with separate processing paths within the attention mechanism.
And for those multi-shot videos you mentioned earlier, keeping things consistent.
That's where their multi-shot MMROP comes in. ROP is a kind of positional encoding. Their version is 3D, understanding video structure, and it's designed to handle sequences where different text prompts might apply to different shots within the same generated video.
So it helps the model keep track of which instruction applies to which part of the story.
Essentially, yeah. It's key for training on and generating coherent multi-shot sequences.
It sounds like a really flexible setup. How do they actually train one model to do both text to video and image to video? Seems like different tasks.
They use a unified approach during training. The model always gets a noisy input, and the conditioning changes. Sometimes it's just text for T2V, sometimes it's an image, plus maybe some text describing motion for I2V.
So they just mix the tasks together during training.
Yep. By varying the proportion of each task type, the model learns to handle both within that single framework.
Clever. And for high-res output, like 1080p, you mentioned a refiner.
Right, a cascaded system. The main DIT model generates a base video, maybe at 480p. Then a separate diffusion refiner model takes that lower res output.
And bumps it up.
Exactly. It upscales it to 720p or 1080p. This refiner is specifically trained to add detail and texture, using the low-res video as a guide. It's often more efficient than making one giant model do everything from scratch.
Wow, okay. So it's really a system, not just one monolithic model. Let's talk training then. It sounded like multiple stages.
It really is. They built it up progressively. Pre-training first, just learning the basics of video data. Started low-res, gradually increased resolution and frame rate for smoother results.
Starting simple, adding complexity. Makes sense.
Then a continued training phase. Here they upped the proportion of image to video data, used higher quality selections, and focused on improving I2V performance specifically.
Okay, strengthening that specific skill. Then supervised fine-tuning, SFT.
Right. SFT uses a much smaller but very carefully chosen data set.
Yeah.
They curated examples covering specific styles, complex motions, things humans care about.
So targeted improvements based on human curation.
Exactly. Fine-tuning on these specific data sets helps align the model better with desired outputs for certain use cases.
And then the big one, RLHF, reinforcement learning from human feedback.
Yeah, but a video-specific version. They call it multi-dimensional RLHF.
What do you mean?
Instead of just a single good or bad score, they got human feedback on multiple aspects. Motion quality, aesthetic quality, and prompt following.
Oh, so breaking down goodness into different dimensions.
Precisely. They trained separate reward models to evaluate each of these dimensions. One focused on motion plausibility and vividness, another on visual appeal and detail, and a third on how well it matched the text prompt.
And the main model learns to optimize for all of them.
It learns to generate videos that maximize a composite score based on all those reward models. They found this direct optimization on specific qualities really helped improve alignment. And they applied this to the high-res refiner too, not just the base model.
That's incredibly thorough. Okay, but training is one thing, that 10x speed up. How did they manage that in practice for inference?
It's a mix of things. On the model side, a big one is diffusion distillation.
Distillation, like teaching a smaller model.
Sort of, yeah. You train a faster, simpler model to approximate the output of the bigger, slower one. They used a few different distillation techniques specifically adapted for diffusion models. This lets them drastically cut down the number of steps needed for generation, getting maybe a 4x speed up just from that, while keeping quality high.
Okay, 4x is significant. What else?
They also optimized the VA EDcoder, made parts of it thinner or less computationally heavy, which apparently gave another 2x speed boost without hurting quality.
So model tweaks gave a big chunk of the speed up. What about the systems side? Running it efficiently?
Yeah, that's crucial for real-world speed. They developed custom, high-performance compute kernels for the core operations, things like kernel fusion to combine steps.
Got it. Low-level code optimization.
Right. Plus quantization using lower precision numbers for calculations where possible, and sparsity techniques to make the models smaller and faster. They use fine-grained methods, adapting them specifically for the DIT architecture.
And for handling long videos or big models across multiple DPUs.
Sophisticated parallelism strategies, automatically figuring out the best way to split the work spatially, temporally across the available hardware. Minimizing data movement between chips, which is often a bottleneck.
Smart partitioning.
Yeah, and things like asynchronous offloading, so you could potentially run these big models even if you don't have massive amounts of GPU memory. It's really a full stack effort.
Okay, it sounds like they attacked the speed problem from every angle. So the proof is in the pudding. How does it actually perform against others? We touched on the leaderboards.
Right, the artificial analysis arena, that's a public benchmark based on crowdsourced human preferences using ELO scores. And yeah, as of mid-June 2025, Seedance 1.0 was #1 for both T2V and I2V.
#1 on both simultaneously. That really backs up their claim about balancing the different aspects.
It really does. It suggests it's not just good at one thing, but achieving state-of-the-art across the board, according to user preference.
Did they do their own internal tests too?
Oh yeah, extensively. They built their own benchmark, Seed Video Bench 1.0, using prompts based on real-world use cases, affects e-commerce, that kind of thing.
And what were they measuring there?
Really granular stuff, developed with input from film directors. 4 core dimensions: motion, quality, plausibility, stability. Prompt following, did it do what you asked? Right. Aesthetic, quality, visual appeal, detail. And for I2V, preservation, how well did it stick to the source image?
That's way more detailed than just a thumbs up down. How did it stack up against competitors in those tests?
According to their human evaluations, Seedance 1.0 performed very strongly. For T2V, they noted that while Maybe Clean 2.1 had really strong motion, Seedance was better at actually following the prompt accurately.
Which is arguably more important for practical use.
Exactly. For I2V, they found it matched Kling's motion quality, but again had superior prompt following, especially for complex instructions or transitions. They felt VO3, while realistic, sometimes struggled with motion or preserving the input image details.
Okay. And beyond scores, those specific capabilities like the multi-shot generation.
That's one of the really standout features, I think. Being able to generate multiple connected shots from one prompt, keeping the subject and style consistent, that's huge for storytelling.
Handling actual cinematic transitions within the generation.
Yeah, things like shot, reverse shot, cuts, maintaining coherence. Their examples looked significantly more narrative than just stringing together random clips, which some other models might do.
And the style control. Multi-style alignment.
Also very strong, based on their examples.
Yeah.
Generating different cinematic looks, black and white, retro Hollywood or artistic styles like anime or ink wash, directly from the prompt, and preserving style well in I2V. It seems very versatile.
Lots of examples on their site, I assume.
Yeah, the paper has some, but they point to the website for more visualizations, which really help see the capabilities in action.
Okay, so let's wrap this up. We've gone through the architecture, the data, training, optimization, performance. What's the big takeaway here for someone working in AI? Why does Seedance 1.0 matter?
I think it represents a really significant step in tackling that core trade-off. They've shown it's possible to achieve state-of-the-art results simultaneously on visual quality, motion plausibility, and precise user control.
Especially that control aspect with detailed prompt following and the multi-shot capability. That feels very practical.
Absolutely. And coupling that with the massive speed improvements, it starts to move these kinds of models from research curiosities towards being actual tools.
Right. Tools that could genuinely impact creative workflows, content generation, marketing.
And ByteDance seems to agree. They're planning to integrate it into their platforms like Dubao and Gemeng soon, positioning it explicitly as a productivity enhancer.
So to summarize our deep dive, Seedance 1.0 is a technically impressive video foundation model. Key strengths are its balanced performance, precise control, multi-shot coherence, style versatility, and significantly accelerated inference speed.
Built on meticulous data work, a clever architecture, advanced training like multidimensional RLHF, and serious optimization efforts.
A really comprehensive approach.
Indefinitely.
So as we finish up, thinking about models like this getting so fast, so controllable, able to handle narratives and styles, what does that actually unlock? What new possibilities, maybe even whole new ways of creating or working might emerge really soon because of this?
That's the big question, isn't it? The implications are potentially huge and still unfolding.
Something to keep thinking about. Thanks for joining us for this deep dive into Seedance 1.0. Keep exploring.